everyone. Welcome to SWAM's online lecture series on the topic Database Management System. I am Mohammad Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim City, Aligarh. I am pleased to have you join me today as we explore the fascinating realms of database, data, and database management systems. In the next few minutes, we will journey through the structure query fundamentals. In the previous session, we have discussed closure properties of database management system, relational documentation, relational decomposition, dependency preserving decomposition. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, what is lossless joint decomposition and why it is important in database design? The answer is, lossless joint decomposition involves breaking a relations into a smaller relations without losing any information, ensuring that the original relation can be reconstructed from the smaller one. This process is vital in database design to minimize redundancy, optimize storage, and maintain data integrity. The decomposition a relation while preserving all original dependencies, anomalies like insertion, deletion, and updation anomalies are avoided. It enables efficient storage, improves query performance, and ensures that data remains consistent across the database. Lossless joint decomposition is a fundamental in achieving normalization, a key principle in database designing well-structured and efficient relational databases. Next question was, explain the concept of dependency preserving in lossless joint decomposition. Answer is, dependency preserving in lossless joint decomposition ensure that all functional dependencies present in the original relations are reserved in the decomposition. In the original relation are preserved in the decomposed relation. It guarantees that any constraints or rules defined by these dependencies remain valid even after decomposition. By maintaining dependencies across the decomposed relations, integrity constraints are upheld and data consistency is retained. Dependency preservation is crucial because it prevents the loss of crucial information and ensures that the decomposed relations accurately present the original relations semantics. It supports normalization efforts, enhances database design quality, and helps maintain the database reliability and consistency during data manipulation operation. The third question was, discuss the difference between the lossless decomposition and dependency preserving decomposition. The answer is, lossless joint decomposition ensures that decomposed relations can be joined to reconstruct the original relation without losing information. It focuses on preserving the original relation's structure. Dependency preserving decomposition, on the other hand, guarantees that all functional dependencies present in the original relation are preserved in the decomposed relations. It emphasizes maintaining the dependencies and semantic integrity of data, while lossless joint decomposition ensures the ability to reconstruct the original relation. Dependency preservation decomposition ensure the present dependency preservation decomposition ensure that the preservation of semantic meaning. Dependency preservation, decomposition ensures the preservation of semantic meaning and constraints. Both are essential concepts in database normalization, aiming to minimize redundancy and maintain the data integrity. The last question was explore the impact of lossless joint decomposition on the performance of data operation such as insertion, deletion, and updation records. The answer is lossless joint decomposition minimizes redundancy and maintains the data integrity, but it can impact database operations performance but it can impact database operations performance. During insertion, decomposition may require inserting data into multiple relations, potentially increasing insertion time. Similarly, deletion operations may involve cascading deletes across decomposed relations, slowing down performance. Updating records may also become more complex as updates to attributes involved in the join conditions may require synchronization across decomposed relation, while lossless join decomposition enhances the data integrity and query optimization. It may introduce overheads in database operations due to increased complexity and coordination required among the decomposed relations. So the agenda of the today's lecture is to discuss introduction to a structure queue language, rules, SQL process, characteristic of a structure queue language, advantage of SQL language, disadvantage of SQL language, SQL data types. Introduction to SQL. A structure query language in database management system is a standardized language used for managing relational databases. It allows user to perform various operations such as querying, inserting, updating, and deleting data in a database. The structure query language provides a simple and powerful syntax for interacting with databases, making it easy to retrieve and manipulate data. It supports a wide range of operations, including data definition, data manipulation, and data control. A structure query language stands for a structure query language is used for storing and managing data in relational database management system. It is a standard language for relational database system. It enables a user to create, read, update, and delete relational databases and tables. SQL queries are written using keywords like select, insert, update, delete, and the clause like where, group by, and join to perform a specific task on the database. Overall, a structure query language is essential for database management system and querying in database management system. All the RDBMS like MySQL, Informic, Oracle, MS Access, and SQL Server uses a structure query language as their standard database language. A structure query language allows user to query the database in a number of ways using English-like statements. SQL rule. A structure query language rules in database management system govern the way SQL commands are written and executed to ensure consistency and reliability in database operations. These rules includes atomicity. SQL operations should be atomic, meaning they meaning they either fully complete or have no effect at all, ensuring database integrity. Consistency. A structured query language command should maintain the consistency of a database, ensuring that it remains in a valid state before and after transaction. Isolation. A structured query language transactions should be isolated from each other to prevent interference, ensuring that transactions occur independently and do not affect each other's outcomes. Durability. The structured query language changes should be durable and permanent, even in the event of system failure, ensuring that committed transactions are preserved. Data integrity. A structured query language operation should adhere to constraints and rules defined in database schema, ensuring the accuracy and reliability of the data stored. Adherence to all these rules ensure the reliability, consistency, and integrity of database operations performed using by a structured query language in a database management system. Now let us explain the SQL process. In database management system, the SQL process involves several steps: parsing, compilation, optimization, execution, fetching, and transaction handling. We take one by one. Parsing. The structured query language query is parsed to ensure its syntax is correct and follows the rules of SQL. During parsing, the query is broken down into parse tree, which represent the structure of query and its components. Compilation. After parsing, the parse query is compiled into an internal format that the DBMS can execute. The compilation process involves translating the parse tree into an executable form, which may include generating an execution plan for the query. The next is optimization. Once compiled, the query undergoes optimization to improve its performance. The optimization phase analyzing various execution strategies and selecting the most efficient execution plan based on the factors such as indexes, join algorithms, and access path. Execution. The optimized query is executed against the database. Depending on the path of query, this may involve reading, inserting, updating, or deleting data from the database table. The DBMS translate the query into low-level instructions that interact with the storage engine to perform the requested operations. The next is fetching. If the query retrieves data, for example, select a statement, the results are fetched from the database. The DBMS retrieves the data based on the execution plan and returns it to the user or application that used the query. Transaction handling. If the structured query language query involves transaction, for example, insert, update, delete, the DBMS ensure the ACID property of transactions. Characteristic of SQL. SQL exhibits several key characteristics that make it powerful tools for managing relational databases. Firstly, SQL is a standard query language ensuring consistency and compatibility across different database management systems. Secondly, a structured query language is declarative, allowing user to specify what data they want to retrieve or manipulate without needing to specify how the database should perform the operation. SQL is easy to learn. It is used to access data from relational database management system. It can execute queries against the database. It is used to describe the data. It is used to define the data in database and manipulate it when needed. It is used to create and drop the database and table. It is used to create view, stored procedure, functions in database. A structured query language allows user to set permission on tables, procedures, and views. Advantage of SQL. SQL standardizes database interactions, ensuring consistency across the statement. Ensuring consistency across systems. Its declarative nature simplifies development, allowing users. Its declarative nature simplifies development, allowing user to focus on the desired documents. SQL offers powerful query capabilities, enabling efficient data manipulation and analysis. It also supports data integrity and security features, ensuring reliability and confidentiality in database operation. High speed, no coding needed, well-defined standard, portability, interactive language, and multiple data view. Let us explain one by one. High speed, using a structured query, the user can quickly and efficiently retrieve a large amount of record from a database. No coding needed. In a standard SQL, it is very easy to manage the database system. It does not require a substantial amount of code to manage the database system. Well-defined standards, long established, are used by the SQL databases that are being used by ISO and ANSI. Portability. SQL can be used in laptop, PCs, server, and even some mobile phones. Interactive language. A structured query language is a domain language used to communicate with the database. It is also used to receive answer to the complex questions in seconds. The last is multiple data views. Using the SQL language, the user can make different view of database structure. Disadvantage of a structured query language. SQL, despite its advantages, present challenges. It can be complex for beginners due to the extensive syntax. Advanced features like procedure programming are lacking. SQL queries may be inefficient with large database sets. Security risks like SQL injection exist. Nevertheless, SQL remains a powerful tool for managing database in various scenarios. Complexity, next advantage, scalability, performance, schema rigidity, and concurrency control. SQL data types. In database management system, SQL data types define the types of data that can be stored in a column of a table. Each column in a table must be assigned a specific types to ensure the data integrity and efficient storage. SQL provide a wide range of databases to accommodate different types of data, including numeric values, strings, dates, and binary data. Here are some common SQL data types. Binary data types used for storing binary data such as images, documents, or multimedia files. Example includes blob, binary large object, and binary. Numeric data types used for storing numeric data type such as integer, decimal, floating point number. Example includes integer, big int, a small int, decimal, and numeric. Character data types used for storing alphanumeric characters and text string. Example includes car, vacha, and text. Date and time data types used for storing date and time values. Example includes time, date, time, and timestamp. Boolean data type used for storing true, false, or Boolean values. Some databases supports Boolean as a data type while others use tiny int or char to represent a Boolean values. Other data types, structured query language also provides data types for a specialized purpose such as UUID, universally unique identifier, XML, JSON, and array. SQL features. SQL offers several features in database management system to efficiently manage relational database. These are data queuing, data manipulation, data definition, data control, transaction control, data integrity, join, aggregation, subquery, and views. Data queuing. Structured query involves powerful querying capabilities to retrieve a specific data from database using select statement. Data manipulation. SQL support insert, update, and delete a statement to add, modify, and remove data from the tables. Data definition. SQL allows the creation, alteration, and deletion of database objects such as tables, views, indexes, and constraints using create, alter, and drop statements. Data control. SQL provides commands like grant or revoke to manage access permission, allowing users to control who can access and modify data in the database. Transaction control. SQL support transaction to ensure data consistency and integrity by providing the command like commit, rollback, and save point. Data integrity. SQL enforces data integrity constraints such as primary key, foreign key, unique constraints, and check constraints to maintain data accuracy and consistency. The next is join. SQL enable the combination of data from multiple tables using join operations such as inner join, left join, right join, and full join. Aggregation. SQL supports aggregate functions like sum, average, count, min, and max to perform calculations on the group of rows and generate summary operations and generate summary information. Subqueries. SQL allows the nesting of queries within the queries to perform complex operation and retrieve data based on conditions specified in the subquery. Views. SQL enables the creation of virtual tables called views, which are derived from one or more underlying tables and provide a convenient way to access and manipulate data. SQL application. SQL applications. Structured query language finds numerous applications in database management systems for efficiently managing relational database. Some common SQL application includes data retrieval. SQL enable user to retrieve a specific data from the database using select statement, allowing for precise query based on criteria such as conditions, sorting, and grouping. Data modification. SQL supports insert, update, and delete statements to add, modify, and remove data from the tables, ensuring that database remain accurate and up to date. Database creation and modification. SQL allow the creation and alteration and deletion of database objects such as table, views, indexes, and constraints using create, alter, and drop statement, enabling flexible database schema management. Access control. SQL provide command like grant, revoke to manage access permissions, allowing users to control who can access and modify data in the database, enhancing security. Transaction management. SQL support transactions to ensure data consistency and integrity by providing commands like commit, rollback, save point, facilitating reliable data manipulation. Data integrity enforcement. SQL enforce data integrity constraints such as primary key, foreign key, unique key constraints, and check constraints to maintain data accuracy and consistency, ensuring data quality. Data analysis and reporting. SQL support aggregate function like sum, average, count, mean, and max to perform calculations on the group of rows and generate summary information, facilitating data analysis and reporting tasks. Data migration and integration. The next is data maintenance. And the last is stored procedure and function. SQL allows the creation of a stored procedure and functions which are precompiled SQL statements stored in the database and executed as needed, providing reusable and efficient code for common tasks. Let's now understand what is NoSQL database. NoSQL databases are not only SQL, are a category of database management system designed to handle large volume of unstructured or semi-structured data. They offer flexibility in data modeling, scalability, making them suitable for modern applications like web, mobile, IoT, and real-time analysis. NoSQL databases come in various types, including document-oriented, key-value, column family, and graph databases, each optimized for different use cases and data models. They excel in scenarios requiring fast data ingest, flexible schemas, and horizontal scalability, offering an alternative to traditional relational bases for modern data intensive workload. Now let me discuss some of the important advantage of NoSQL. Here are concise application of advantage of NoSQL database in DBMS for academic purpose. Scalability. NoSQL databases offers scalability, allowing academic projects to handle large volume of data and high traffic load. This is beneficial for research projects that involve processing large database and simulating real world scenarios. Flexibility. NoSQL database provides flexibility in data modeling, enabling researchers to work with various data structures and schemas. This flexibility supports experimentation and exploration in academic setting where data requirements may evolve over time. High performance. NoSQL databases prioritize performance, offering fast data access and processing capabilities. This is advantageous for academic projects that require efficient data retrieval and analysis, such as real-time data processing or simulation. Support for big data. NoSQL database excel in handling big data, making them suitable for academic research involving large-scale data sets. High availability. NoSQL databases are designed for high availability, ensuring continuous access to data. This reliability is valuable for academic projects that requires uninterrupted access to data for experimentation, analysis, and collaboration. The last is cost effectiveness. NoSQL databases can be cost effective. No academic institutions and researchers, as they often have lower licensing cost and harder requirements compared to the traditional relational databases. Disadvantage of NoSQL. Here are some of the key disadvantages of NoSQL databases: lack of standardization, limited query capabilities, consistency and transaction support, data durability concern, and the last is learning curves. Difference between SQL and NoSQL. The main difference between SQL and NoSQL database in DBMS can be summarized in terms of data model and query language. Data model. A structured query language database follow a structured tabular data model based on the relational model. Data is organized into tables with row and columns, and relationship between tables are established using foreign keys. NoSQL databases offer a variety of data models, including document-oriented, key-value, white column, and graph-based models. These data models provides more flexibility in representing and storing data, allowing for schema-less or schema-flexible designs. Query languages. Structured databases. SQL databases uses SQL query language for data manipulation and retrieval. SQL provides standardized syntax for performing crude, create, read, update, and delete operations, as well as complex queries involving join, aggregations, and subqueries. NoSQL database may use different query languages or APIs depending on the data model. For example, document-oriented NoSQL database often use JSON-based query language, while key-value stores may use simple key-based access methods. In today's lecture, we discuss about the normalization for structured query fundamentals. Now let's access your knowledge and track your progress with some important questions. Your answer will enhance your concepts as well as make you more aware about the topic. The today's question to test your knowledge are: explain a structure query process in details, describe some key features of SQL, what are the basic data types supported in SQL, explain difference between SQL and NoSQL in detail. In our exploration today, we have discussed the new and very important topics of database management systems. This is a structure query language fundamentals. In today's lecture, we have discussed fundamental of a structure query language along with its advantage and disadvantages. I hope you enjoyed this lecture. Hope to see you soon in the next lecture. Thank you very much.